Okay, section 7.1 angles, page 3. I am quickly realizing that I am not leaving enough space on these notes, so I will make sure to get better with that in subsequent sections. First things first, though, we just talked about the formula for circumference of a circle when it has radius 1. And the reason we look at radius 1 is because all of our circles are similar. They all look the same way, so they're all going to be in proportion. So sometimes it's just easier to take a look at the basics. Okay? Degrees are great if we are talking about rotating around a point. A lot of times, though, when we're talking about circles, we want to measure a straight line distance. And so here's what we're going to do. We're going to define radian. And a radian is the measure of the angle that intercepts an arc that is equal to the length of the radius. So basically, a radian is how many times we can wrap a radius around its circle. Okay? And so when our radius is 1, we got that circumference of 2 pi. That means it takes 2 pi radians to go all the way around a circle of 360 degrees. That's what that says there. Okay? And so if it's 2 pi radians all the way around, if we go halfway around, that's just going to be 1 pi. So 1 pi radian is 180 degrees. Okay? So a radian has to be a real number. We have got 1 pi radian equals 180 degrees, and so people sometimes wonder, students often wonder, how big is 1 radian? Well, if pi radians is 180 degrees, one of the things that we tend to forget is that pi is just a number. We approximate it with 3.14, but we can divide by pi like we divide by any other number. And that way we get the measure of 1 radian is a little more than 57 degrees, about 57.3 degrees. And so that's how big our 1 radian is. Okay. It's important that we're able to convert from degrees to radians. And so we're going to use this conversion factor here. We're going to use the fact that pi radians, like we just said, is 180 degrees. So right here I've got pi radians. Oh, that's super helpful. 180 degrees. Okay. And I'm going to come over here to do 7a where I have a little more room. Okay. So 7a. We have got 60 degrees. We want to convert to radians, and so I'm going to put my pi radians in the numerator. I'm going to put my 180 degrees in the denominator. One thing that we want to remember is that units cancel. So here our units are degrees. They cancel just like numbers do. So if I have degrees in the numerator and degrees in the denominator, I can cancel those. So now I get 60 times pi, the only unit I have left is radians, over 180. 60 goes into 180 evenly, so we can reduce that and we get 1 pi over 3 radians. Okay, let's see if we can get them all over here on this side, and then we'll do 8 on the other side of the page. So 7b, we've got 390 degrees. Again, times pi radians over 180 degrees. We are going to make sure that we are conscious of why we are multiplying the way we are. We're going to cancel those degrees. And easy reduction, 39 pi over 18. 3 goes into both 39 and 18, so we get 13 pi over 6. Again, our unit is radians. And a lot of times you'll just see something left as 13 pi over 6. We really don't want to lose that label. Okay, 7c, we have a negative 450 degrees. We are just going to keep doing what we've been doing. So times pi radians over 180 degrees, because that is our conversion factor. Pi radians equals 180 degrees. We are canceling the degrees. And that gives us, again, a negative 45 pi over 18 radians. 9 goes into both 45 and 18. I get negative 5 pi over 2 radians. Okay. And so if you take a look at the PDF of the notes, you will see these listed. Work is a little neater. Okay. So, fill those in here. 60 degrees was pi over 3 radians. 390 degrees, 13 pi over 6 radians. And negative 450, we had negative 5 pi over 2 radians. Okay. So let's see if we can go, we're just going to go let me go a page over. Nope. Okay, other side. We've got 7D, 90 degrees times pi radians over 180 degrees. We're canceling degrees again. 90 over 180 is 1/2. 1/2 pi radians. Usually we put the pi in the numerator and we have pi over 2 radians. (7e) negative 270 degrees. Our degrees are canceling. Negative 27 over 18, 9 goes into both of those. We end up with negative 3 pi over 2 radians. And 7f. 45 degrees. Times our pi radians over 180 degrees. We are going to cancel degrees. We get 45 over 180, which reduces to pi over 4. And there is D, E, and F. This app does not handle that small print really well. We'll fix that. Okay. 8. We want to convert from radians to degrees. Now there's a couple of things that I want to point out. If we take a look at, let's see if we can make this a little smaller. If we take a look at what it says right here, we have two options for doing this. I can multiply by 180 degrees over pi, or I can take every pi and replace it with 180. And so let's take a look at why it happens that way. And so what I'm going to do is I'm going to slide over here real quick. Just take a blank page and do these separately. So 8a, we have pi over 6 radians. Okay, now, here's what happens. Here's our conversion factor. I want radians to cancel. So I'm going to put radians in the denominator. My degrees are going to go in the numerator because I want to keep the degrees in there. Just like before, change color so that we can cancel the radians in both. Notice here though that pi also cancels, which is what makes this a little easier for us sometimes. This is 180 degrees over 6. We get 30 degrees. 8b, we have 7 pi over 8 radians. Again, same conversion, 180 degrees over pi radians. My radians cancel, the pi's cancel. I have 7 times 180, which is 1,260 degrees, divided by 8, and we get 157.5 degrees. 8c looks a little different. I got 0.8021 radians. A little unsettling here. I can't just plug in the 180 for pi because I do not have a pi in there. I can still convert the same way. I'm multiplying this by 180 degrees over pi radians. My radian label still cancels. I multiply my two numerators. I get 144.378 degrees over pi, which ends up being 45.96 degrees if we round correctly to 2 places. Our last one, D, we're back to having a pi in here. And this is one of those places where it's super easy to just replace that pi radians with 180 degrees. 4 times 180, we get 720 degrees. And there's problem 8, much easier when I'm not trying to cram it in on that little sheet. Lessons learned. This is a new app for me, so these will get better. Okay, so let's talk about these angles. Standard position. So again, we got to start with our initial side along that positive x-axis. This is a negative angle. I know I'm going in the negative direction. Keep in mind, halfway around, this is pi. If I want pi divided by 6, I'm going to take a look at what dividing that half of the circle into 6 pieces would be. So there is my negative pi over 6. B, we've got 3 pi over 7. Here's my initial side. That's not going anywhere. And so let's think. 7 pi over 7 would be halfway around the circle. Half of 7 pi is 3.5. So I'm going to be a little shy of half of the top half of the circle. We're going in a positive direction. There is my 3 pi over 7. C, negative 4 pi over 5. I have got my initial side in the same place. Halfway would be 5 pi over 5. So I want to go 4 out of 5 pies, 4 out of 5 pieces in the negative direction, and there is my negative 4 pi over 5 angle. And that's it for page 3.